The exponential notations are the way floating real numbers are denoted in the computers. That video will tell you what the exponential notation or scientific notation is from a mathematical point of view. What is the exponential notation? It is the number with an e inside. For instance, 7.7e plus 9 or 3.2e minus 6. It is encountered on scientific calculators and also on computers. It is used for floating real variables format. How do I read an exponential notation? 7.7e plus 9 is read 7.710 to the power 9 or 7,700,000,000. (3.2e minus 6 is read 3.210 to the power minus 6 or 3,200,000,000). The exponential notation relies on the powers of 10. It is the exponent part, the part after the e. What are the positive powers of 10? It is iterated multiplications of 10 by itself. Ten to the power k is read 10 to the power k, k positive integer. 10 to the power 1 is 10. 10 to the power 2 is 10 multiplied by 10, that is 100. 10 to the power 3 is 10 multiplied by 10 multiplied by 10, that is 10 multiplied by 100 or 1000. And we continue. 10 to the power k is 10 multiplied by itself k times, and it is also a 1 with k zeros. But in exponential notation, we multiply decimal numbers by positive powers of 10. Multiply an integer n by 10 to the power k is add k zeros to the right of n. For instance, 13 multiplied by 10 to the power 3 is 13,000. Multiply a decimal by 10 to the power k is shift the decimal point by k position to the right. For instance, 2.45 10 to the power 2 is 245. If the last digit is encountered before the end of the shifting, we must add as much zeros as needed to the decimal part. For instance, 7.7 multiplied by 10 to the power 9 is 7,700,000,000. And if we want to multiply positive powers of 10 together, we must add the exponents. Let k and l be positive integers. Then 10 to the power k is a 1 with k zeros. And 10 to the power k multiplied by 10 to the power l is addition of l zeros to 10 to the power k. So 10 to the power k multiplied by 10 to the power l is a 1 with k plus l zeros. Thus we have the formula 10 to the power k multiplied by 10 to the power l is 10 to the power k plus l. So if we multiply powers of 10 together, we add the exponents. But what is 10 to the power 0? A consistent definition of 10 to the power 0 is 10 to the power 0 equals 1. This is because taking 10 to the power a number transforms multiplication in addition, and 1 is the neutral element for the multiplication and 0 is the neutral element for the addition. Now we are ready to define the exponential notation with non-negative exponents. xe plus k, where x is a decimal number and k a non-negative integer, is x multiplied by 10 to the power k. For instance, 2.45e plus 2 is 2.45 multiplied by 10 to the power 2, 100, and it is 245. 2.45e plus 1 is 2.45 multiplied by 10 to the power 1, 10, and it is 24.5. 2.45e plus 3 is 2.45 multiplied by 10 to the power 3, 1000, and it is 2450. 2.45e plus 0 is 2.45 multiplied by 10 to the power 0, that is 2.45 itself. But the exponential notation tells us much things about the range of the real number they represent. By convention, x in xek is called the mantissa, and it has only one digit before the decimal point that is non-zero, so that x is between 1 and 10, 10 excluded. So that xek is between 10 to the power k and 10 to the power k plus 1, 10 to the power k plus 1 excluded. Note that the negative real numbers are not considered in that video. Exponential notation with positive exponent deal with medium to big order of magnitude. This is because add 1 to the exponent multiplies the number by 10. For instance, 2.45e plus 3 is 10 times 2.45e plus 2. Subtract 1 to the exponent divides the number by 10. For instance, 2.45e plus 1 is 2.45e plus 2 divided by 10. And two numbers with the same exponent are in the same range, 10 to the power k, 10 to the power k plus 1 excluded, with 10 to the power k plus 1, that is 10 times 10 to the power k. So the exponent is related to the order of magnitude. The small non-negative exponents, say 0, 1, and 2, represent the medium orders of magnitude. For instance, 1 is with an exponent 0, 20 is with an exponent 1, and 999 is with an exponent 2. The bigger exponents, for instance 3, 4, and 5, represent bigger orders of magnitude. For instance, 1000 is with an exponent 3, 20,000 is with an exponent 4, and 999,999 is with an exponent 5. The bigger the exponent is, the bigger the order of magnitude is. For instance, with the light speed c equal approximately 300,000 kilometers per second, it is 3e plus 5 kilometers per second, but 3e plus 8 meters per second. It is a far bigger order of magnitude. And now let's invert positive powers of 10 to get negative powers of 10. 10 to the power minus k with k positive integers is read 10 to the power minus k and is equal to 1 over 10 to the power k. For instance, 10 to the power minus 1 is 1 over 10, that is 0.1. 10 to the power minus 2 is 1 over 100, that is 0.01. 10 to the power minus 3 is 1 over 1000, that is 0.001. And we can continue. And 10 to the power minus k is 1 over 10 to the power k, and it is a 0, then a dot, then k minus 1 zeros, and a 1. And so on. Let's multiply by a negative power of 10. Multiply an integer n by 10 to the power minus k is add a decimal point at the right of n, then shift it by k positions to the left. For instance, 1348 10 to the power minus 3 is 1.348. If the first digit is encountered before the end of the shifting, then you may add a 0 before the dot and as much zeros as needed to the decimal part. For instance, 13 multiplied by 10 to the power minus 4 is 0.0013. Multiply a decimal number by 10 to the power minus k is shift the decimal point by k positions to the left. For instance, 432.45 multiplied by 10 to the power minus 2 is 4.3245. If the first digit is encountered before the end of the shifting, then you must add a 0 and a dot, and then as much zeros as needed to the decimal part. For instance, 2.45 multiplied by 10 to the power minus 4 is 0.000245. Multiply negative powers of 10 together is add the opposite of the exponents. Let k and l be positive integers. Then 10 to the power minus k is a 0, a dot, k minus 1 zeros, and a 1. If you multiply 10 to the power minus k by 10 to the power minus l, you have to shift the decimal point by L2 positions to the left, filling with L zeros. So 10 to the power minus k multiplied by 10 to the power minus l is a 0, a dot, k plus l minus 1 zeros, and a 1. So 10 to the power minus k multiplied by 10 to the power minus l is 10 to the power minus k plus l. You add the opposite of the exponents. What is the exponential notation with negative exponents? X e minus k is x multiplied by 10 to the power minus k. It is the product of the decimal x and 10 to the power, the negative integer, minus k. For instance, 12.45 e minus 1 is 12.45 multiplied by 10 to the power minus 1, that is 1.245. 12.45 e minus 2 is 12.45 multiplied by 10 to the power minus 2, that is 0.1245. 12.45 e minus 3 is 12.45 multiplied by 10 to the power minus 3, that is 0.01245. What is the mantissa, the exponent, and the range in negative powers of 10? By convention, in x e minus k, x is called the mantissa, and x has only one digit before the decimal point that is non-zero, so that x is comprised between 1 and 10, 1 included and 10 excluded, so that xek is comprised between 10 to the power minus k and 10 to the power minus k plus 1, that is minus k minus 1. And now with the negative powers of 10, we can go from medium down to small orders of magnitude. Add 1 to the opposite of the exponents minus k divides the number by 10. For instance, 12.45 e minus 3 is equal to 12.45 e minus 2 divided by 10. Subtract 1 to the opposite of the exponent minus k multiplies the number by 10. For instance, 12.45 e minus 1 is 10 times 12.45 e minus 2. And two numbers with the same exponent are in the range 10 to the power minus k, 10 to the power minus k minus 1, with 10 to the power minus k minus 1 is 10 times 10 to the power minus k. So the negative exponent represents the order of magnitude of the small number. The negative exponents close to 0, say minus 1, minus 2, and minus 3, represent the medium orders of magnitude of small numbers. For instance, 0.99 is 9.9 e minus 1, 0.02 is with the power minus 2, and 0.001 is with the power minus 3. The more negative exponents, say minus 4, minus 5, and minus 6, represent smaller orders of magnitude with number closer to 0. For instance, 0.00099 is 9.9 e minus 4, 0.00002 is with the power minus 5, and 0.000001 is 1 e minus 6. And the more negative the exponent is, the tinier the order of magnitude is, closer and closer to 0. For instance, the diameter of a molecule might be d equal 3 micron, that is 3 e minus 6 meters, that is a 0 with 5 zeros and a 3 in meters. And this is the end of that video about the exponential notation and the powers of 10. Hope you have learned many things. And don't hesitate to visit our website, mathedu.academy. You will learn even more.